Hello everyone, what's up? So today in this video we'll be solving this question called rotate image, which is one of the most commonly asked questions by Facebook as mentioned by Leetcode. And if you like watching these videos, then please do consider subscribing to this channel, and sharing it with your friends would really help support the reach of this channel. So we'll discuss the question and then we'll move on to its explanation part as well as the code. So the question says that we are given an n cross n 2D matrix which represents an image. So we know images are represented using pixels, x and y coordinates, and we need to rotate this image by 90 degrees in the clockwise direction. So they mentioned the rotation degrees required as well as the direction. And also you need to rotate this in place, which means we cannot use any extra space to store anything. And so they have given some examples. For example, the first row here becomes the last column for 90 degree clockwise rotation, then 4, 5, 6 second row becomes the second column, and third row becomes the third column. Similarly for this case, and for a single cell matrix, single element, we'll simply return the same thing. So these are some test cases. Let's quickly move on to its visualization, how we'll do it without using extra space, and then we'll write its code. Alright, so let's start with the explanation part now. So in this particular test case, I have considered this matrix as the input matrix. So it's 3, 4, 2, 7, 6, 8, and 9, 1, 0. And when we rotate it by 90 degrees clockwise, so our output is this A dash matrix, which is 9, 7, 3, 1, 6, 4, 0, 8, 2. So you can clearly see that this row has become this particular column. And similarly, the second row is now the second column, and the last row is the first column. So this is how our matrix will look when it gets rotated by 90 degrees. So in order to solve this, the first thing you can do is, of course, something like a brute force approach. So you can have an additional matrix, let's call it B, for example, and B will also be 3 cross 3 of the same size. And what we're doing here is simply we're iterating over all the rows, and we are storing them as columns towards the right hand side, because we know that we want to rotate it by 90 degrees clockwise. So essentially in this case, we iterate towards the first row 3, 4, 2, we store it as the column here 3, 4, 2. Then we iterate over the second row 7, 6, 8, so we store it as the second column, and then for the third row we store it as the third column 9, 1, 0. And so this B matrix is now our result, and we can simply return this matrix as our rotated version of the original matrix. So in this method, what we're doing is we are iterating over all elements of the original matrix. So this is going to be n square time, because there are n square elements, and space wise also this is going to take big O of n square space. Why? Because this matrix that we are creating requires n square elements to be stored. So this is where the additional space comes in. Now in this question on Leetcode, we have clearly been told that we cannot use any extra space. We need to do this in place. So let's discuss that optimized approach now. So now for this optimized approach, we will need to look at some patterns and identify some common patterns in the question. For example, in this case, this is the first row, which actually becomes our last column in the resulting matrix, right? And similarly, the second row becomes the second column, and so on. So this method generally involves 2 steps. First is to take the transpose of your original matrix, and then to reverse either some rows or some columns accordingly, like whichever rotation you want, clockwise, anti-clockwise, based on that. So for example, if I take A transpose, so transpose, if you don't know, it's basically changing all the rows to the columns. So for example, in this case, the first row 3, 4, 2 will become the first column. So 3, 4, 2 comes here. Similarly, second row becomes the second column, 7, 6, 8, and the third row will be our third column, 9, 1, 0. So this matrix is called transpose matrix of our original A matrix. And now if you check these two, the matrix that we want and our current transpose matrix, so you can clearly see that every row is actually reversed in our resulting matrix. For example, if I reverse the first row, I'll get 9, 7, 3. Then if I reverse the second row, I'll get 1, 6, 4. And if I reverse the last row, I'll get 0, 8, 2. And now this matrix is exactly the same as the result that we wanted. So we can simply return this matrix, and we realize that we can make changes inside the same matrix itself. So this is done in place, and for this, of course, what we're doing essentially is taking the transpose at the first step. So this is my first step, and then this is my second step, where I simply reverse all the rows in this case. So depending on the rotation required, you'll have to reverse either rows or columns accordingly. So if I talk about the complexities for this one, so firstly we are just iterating over all elements and transposing them. So the time complexity for that step will be big O of n square, and also for reversing all the rows, you need to iterate over all the rows and reverse every element, every column of that row. So again, that would also be n square. So the total time will be big O of n square. And to talk about the space, so in this case, we are not actually using any extra containers. We are doing this in place itself. So the space will be constant, which is what was required according to the Leetcode question. And now let's also quickly discuss how to take the transpose. So what we're doing in the transpose part is we are changing every element. For example, this is the row 0, 1, 2, and this is the column index 0, 1, 2. So let's consider any random element. For example, this element, its current coordinates are 0, 1. Now all we need to do is replace their x and y coordinates. So for this one, in the transpose matrix, this will be 3, 4, 2, 7, 6, 8. And 9, 1, 0. So in this matrix, that element comes at this position, which is the coordinate 1, 0. And this is what we need to do for every element. So we'll iterate over all the rows and we will make these swaps. But one thing that we need to make sure is after we're done for the first half, that is the upper triangular matrix, we should not make these swaps again, because that will again bring the elements back to their original position. So we'll only need to make swaps for this upper triangular part of the matrix, and this will convert it to its transpose. And now let me quickly consider one more case. For example, if the question was to rotate the matrix 90 degree anti-clockwise, that is towards the left hand side, so our approach would be somewhat similar, but we just need to make sure of the reversals. So the first step again will be the same. We take the transpose of our original matrix, which converts it to this matrix, and now for this matrix, all we need to do is the reversal of rows or columns. So our second step will in this case be the reversal of columns instead of rows, because if you look at the resulting matrix for the rotation towards the left, so you can clearly make sense that the first column is actually the reverse version of the first column. Second column is also the reverse version of the second column, and similarly for the third column. So once we take the transpose, in this one we'll simply reverse the columns instead of the rows in the same manner. So its time will again be O of n square, and space we are not using any extra containers, so it's going to be constant. And in this way you can also try to figure out some patterns for any other cases. For example, if the rotation required is, let's say, 180 degrees, or if it's 270 degrees, so in these cases also, clockwise or anti-clockwise, you can consider constructing the actual resulting matrix and then figure out some patterns after the transpose part. So either reversal of rows or columns, and you'll get your result. So yeah, that's pretty much it about this explanation. This is the required space and time. So let's quickly move on to writing its code, which is going to be pretty simple in this case. Alright, so let's jump to the coding part now. So we are given this function called rotate, which accepts vector of vector. So if you're using Java, then this must be array list of array list, which is called matrix, and we need to rotate it by 90 degrees and return it. We don't actually need to return anything because we need to do this in place. So they'll probably call this same matrix later and try to check if it's rotated or not. Okay, so before starting, first things first, let's finalize the number of rows and columns in this matrix. For rows, I can simply use matrix.size, which is going to give me the number of rows in this matrix, and for columns, I can use something like matrix of 0, which is the first row, so the size for the first row, which is the number of elements in this column. So once we have the rows and columns finalized, we can quickly move ahead. So as we discussed in the explanation part, the first part of this algorithm is to take transpose of the matrix. Take transpose of the matrix. So let's do that first. So we'll iterate over all the rows first. For all the rows, what we'll do is we'll iterate for all the columns as well, but only to the upper triangular part. So what I'm saying is, we'll iterate as long as the column index is less than the row index, which means for the first row we'll iterate over all the 3 columns, then for the second row only for 2 columns, and then for the third row only for the first column. So that is the upper triangular part. So this is done because you don't need to replace the element again, because that is going to convert the matrix after being transposed back to its original form. So once we are rotating over the upper triangular, we can simply replace the elements. So for replacement, I can simply use the swap function for C++, STL. So we are simply replacing an element at the current row and current column by the element for which the row is the column and the column is the row. So just change the coordinates and that's it. So this is basically replacing the elements. Also, if you're using Java, so swap function, this function is not available in Java by default. So you'll probably have to use a temporary third variable to make the changes, and that's how you can swap. After we have the transpose, we can simply move on to the second part. So the second part consists of either reversing some columns or some rows. In this case, because we've already discussed that we need to reverse the rows, so I can simply call it for reversing the rows. And what we'll do here is we'll iterate again over all the rows. So for all the rows, what we'll do is we need to reverse this entire vector for this row. So C++ has this function for reverse, which is simply using the STL. You can simply call for a particular vector. So I'm calling for the current row, and it takes the beginning iterator as well as the ending iterator. Iterator is basically just a pointer pointing to a starting and ending element. So these are the iterators which will be passed, and this line essentially will reverse my current row. And I'm doing this for all the rows, so all the rows will be reversed. Again, if you're using Java, then this reverse function might not be available. So you can use a 2-pointer method to simply reverse the rows using starting and ending pointer. And yeah, that's actually pretty much it, because in this function we are not required to return anything from this, and we have done this entire thing in place using constant extra space. And I hope the matrix is rotated now, so we can try to run this code to check for the sample test cases. So yeah, it's working for the sample test cases. Let's try to submit this. And yeah, it's getting accepted with a pretty good runtime, 100%, and the space utilized is also very efficient because we're not using any extra space. This is constant in terms of space being done in place. So yeah, that was about it for this particular question. So if you're liking such videos and if you appreciate this effort, then please do subscribe. It means a lot. And please do share it with your friends, your network and contacts. So that would be really helpful for the channel. And yeah, thank you for watching. I'll see you very soon in the next one.